Bismillahirrahmanirrahim. I am Imran Riaz, PhD student, School of Electrical and Electronics Engineering, University of Science, Malaysia. I am thankful to the management of the IEEE International Conference on Applied Electronics and Engineering 2024 who spared their time to review our manuscript, and finally we got the acceptance, and today I got the opportunity to present my paper. My paper presentation title is basically the related to biometrics, and this is the dorsal finger crease classification system using local binary pattern and its different variants. The presentation outline is introduction, the literature review, then I will come to the proposed methodology. After methodology, I will explain the results, and I will give some discussion about the experimental results, and finally I will conclude my presentation. Uh, as we know that in the today's world, the biometric identification or the secure identification system is very common, and everyone wants some security system. If in industry, organization, even school attendance system, you can see that everywhere there are some applications where biometric recognition systems are being used. So among different biometric systems, including face, iris, your hand gesture, signature, the hand-based modalities are most commonly used due to various reasons. Some of them are very easy and less expensive to collect the data because the acquisition devices or the image acquisition devices are not so costly, and they are reliable, they have the long lifespan, and the user acceptability. Users are more comfortable to give their data set, to give their images rather than to give the face images. So in this slide, you can see the two views of the hand. One is the inner surface and the other one is the outer surface. If we consider the outer surface, first we consider inner surface because the fingerprints is most commonly used by metric trade. And other than fingerprint, the finger veins from the inner surface of the hands are being used, and also the palm print. So if you see the outer surface of the hand, there are the fingernails, the finger knuckles. Finger knuckles mean this bending point knuckles, and the dorsal hand veins, which are available at this position. They are also being used for the biometric purpose. So if overall we discuss these all three outer surface, three inner surface biometric traits, you will see that the fingerprint is the most commonly and widely used and acceptable biometric trait across the globe. But there are some issues. The persons who are working in submarines, the persons who have skin diseases, cancer patients, there are research studies which I have mentioned in the I have mentioned in the references given below that the people are facing in their fingerprint recognition failure problems. So they need some alternate biometric traits which are available on the outer surface. So in our study, we are going to explore, further investigate this yellow box biometric modality, which is called dorsal finger crease. In our previous research, we have already uh, explored this one. First time we proposed and we investigated this as an independent biometric identifier. In this study, we will give some detailed discussion about the feature extraction, how it can be used more effectively. And also, considering this biometric modality, there are also other biometric traits which are available on a single finger outer surface, fingernail, finger major knuckle, finger minor knuckle. So uh, if we consider this dorsal finger crease for biometric purpose, first of all, we need the data acquisition. Then we have to, if you are not using the deep learning model, we have no big database, then definitely we use some handcrafted feature extraction approaches. Then after finally, we will need classifiers to classify and identify the images. So what is the motivation basically to move this, to do this research work? Considering the feature extraction, which is very important, if we have extracted the actual features rather than the raw data, then it will give high accuracy in our recognition system. And as I discussed, there are some limitations in the existing hand-based biometrics. So there is a need to explore, to search the new modalities. So that's why we consider the dorsal finger creases and the local binary pattern, which have been already used in finger knuckle print classification system, and they have performed very well in classification feature extraction. So they inspired us to use this feature extractor for this new biometric modality. And finally, there will be a comparative analysis of different biometric modalities using different local binary pattern variants with the sport vector machine classifier. If we consider the literature review, in this study, the first one, the biometric systems which are based on the physiological and behavior characteristics, the main key finding was that the hand-based biometric systems or the hand-based features are more reliable and the user acceptance for these systems is very high. And then there is another research study which show that how fingerprints recognition failure occurs, or what are the situations when people lose their fingerprints. Mean there is no fingerprint. Some people have the flat skin diseases. So the persons who are working in chemical industries, doing a lot of cultivation work, working in water or submarines, or high exposure with the water, skin diseases, they are at high risk of losing their fingerprints. Similarly, if we consider the other inner surface hand-based biometric features, considering the hand geometry or the finger vein, there are some problems because these injuries and these skin diseases will ultimately affect the whole inner surface of the hand. And finally, the people will face the recognition problems. Considering the local binary pattern applications in the biometrics, the local binary pattern variants or descriptors have effectively shown excellent results for the outer surface or the dorsal surface hand-based biometrics. So after this brief literature review and introduction, I am going to explain the proposed methodology. In our proposed methodology, first of all, we acquire the data set of the dorsal finger surface fingers images, and then this highlighted portion, yellow portion, we apply the pre-processing techniques to extract the region of interest area of the creases image. And after extracting this ROI, we apply these 6 different binary patterns, including the basic local binary pattern, uniform, average, median, local directional pattern, and the local oriented optimal pattern. And then we apply these LBP variants, and we got the features, LBP based features. This is the LBP image. And after obtaining these features, histograms of these images, we use the SVM classifier for the classification purpose to evaluate the performance. So in next slides, I will explain this section one by one in further more depth. First of all, after data acquisition, we have the pre-processing. Definitely, the raw data or the images which we just have acquired cannot be used directly for the feature extraction or the classification purpose, even in deep learning. We need to do some pre-processing to remove the noise, to remove the unwanted background area. So after this doing cropping and removing the background unwanted area, we got this final ROI of the dorsal finger crease image. When we have the DFC images, pre-processed DFC images, then we will move to the feature extraction. Definitely, the DFC images directly cannot be used for classification purpose. Feature extraction will be more effective to extract the more detailed and the more informative features rather than considering the whole data points of the image. So this is the mathematical calculations of the different local binary pattern variant. Basically, in this slide, we have LBP, uniform LBP, average LBP. Like in basic LBP, we just compare a 3x3 window image, and then the central pixel will be compared with the surrounding pixels. If the intensity of the surrounding pixel is high than the central pixel, the value will be 1, otherwise it will be 0. And finally, we will give them the weights 2 raised to power p, mean 2 raised to power 0, 2 raised to power 1, up to 8. Because there is a 3 cross 3 window, there are 9 pixels, and 1 is a central pixel, and the surrounding pixels are 8. So finally, the ones will be multiplied by the 2 raised to power. And after that, we will add the values, and the final value will be replaced by the central pixel. And this will happen for the whole image structure, 3 cross 3, then 3 cross 3, then 3 cross 3, and this will repeat up till the end of the image pixels, and the previous pixel values will be replaced by the new LBP pixel values. Similarly, in uniform mean the only uniform pattern will be considered, non-uniform pattern will not be considered. Then average LBP, in average LBP, the 3 cross 3 window will be considered, and rather than considering the central pixel, we will consider the average of the 3 cross 3 window as a central pixel, and then that average will be compared with the surrounding pixel. Similarly, then there is the median binary pattern. In median binary pattern, the median will be taken of the 3 cross 3 image patch, and then the surrounding pixels will be compared with the median pixels. And then LDP and loop. And if you see this figure, there are 3 different images shown here. Just as an example, when we apply LBP, you see the fine representation of the dorsal finger lines. Very clear, more uh, informative features are shown and can be easily visualized. When we have extracted the features, then there is a classification stage. We will apply this features histogram to the support vector machine classifier, and we have used the linear kernel. And for the training and testing, 70% of the feature sets are used for the training, and the 30% remaining are used for the testing. And this selection is done as a random selection, not the fixed one. I mean the first 7 and the last 3. Maybe first 2 and the last 5 as a training, and the middle 3 as a testing. So it will be chosen as a randomly. And the evaluation metrics which we have used are the precision, recall, and F1 score. And then finally, the classification accuracy. And after applying this SVM classifier, we have actually the database of three right hand fingers: index finger, middle finger, and ring finger. So when we apply these on index finger, you can see the precision is shown in the red color, the recall is in the green, the gray color is for the F1 score, and the yellow bars are for the classification accuracy in all these three figures. So if we consider basic, uniform, average, median, LDP, and loop, the highest results for all these fingers, three fingers, are achieved in average local binary pattern and the medium local binary pattern among all these three fingers. The reason behind this is in other, the central pixel is considered as a central pivot point, and the surrounding pixels were compared in different scenarios. But in this case, average and the median local binary pattern, the average is taken of the 3x3 image patch, and that features are more robust and more informative as compared to the other LBP, and hence they give more higher classification results as compared to the other LBP variants. And one more thing, if we see the classification accuracy in these fingers, the basic LBP among all these is giving, and the uniform LBP is giving, uniform is giving the lowest, and then the basic. Why uniform is giving the lowest? Because it considers only uniform patterns. So maybe this binary pattern is more suitable for the face recognition system or those biometric rates which have the more diversified features rather than the finger-based biometric traits. Next, there are the identification results. Identification is done basically 1 versus n. One users is compared with the rest of the biometric data available in the database. And for that purpose, we used CMC curves, cumulative match characteristics curves. And in this case, the recognition rate is drawn against the rank. And also in identification results, after classification results, you can see in identification results that again, the median LBP and the average LBP both are giving the best results, the highest identification recognition rate for all fingers as compared to basic, uniform, LDP, and loop. So from all these results, what is the point which we can conclude? That further research on the dorsal finger crease for biometric recognition may be carried out, and this dorsal finger crease can be used as an independent biometric modality for those cases where fingerprint or the inner surface biometric traits are not recognizable. We use the Logitech Pro webcam C920 for the data acquisition. The 6 different variants are used for the feature extraction, and 2 of them, average and median, have achieved the highest accuracy among these 3 different index, middle, and ring fingers. And in future work, we have aimed integrate to propose a multi-model biometric system where we can integrate this finger crease system with the other modalities like fingernails, finger knuckles, or even fingerprints, finger bands, or the face. So it can be more secure and more reliable biometric system. Thank you. If you have any question, you can ask.